Hello, everyone, and a very warm welcome to my channel. Finding the roots of nonlinear equations isn't always easy, but if you could find them without guessing too much or diving deep into calculus. In today's video, we will explore the false position method, also known as Regula Falsi Method, a simple yet powerful technique that blends smart guessing with geometry. And best of all, we will see it live in action using MATLAB with a clean code and an awesome plot to visualize how the method zooms into the solution. So for the development of the code, we need to define the nonlinear function. And for that, we are choosing f of x is equals to x cubed minus x minus 2. After that, we need to set the initial interval ab to 1 to 2 where f of a and f of b have opposite signs. So with the help of MATLAB code, we will check that either f of a and f of b have opposite signs or not. Thirdly, we will apply the false position method in order to find out the root, and for that we will use a for loop, and in for loop we use the formula that is c is equals to a into f of b minus b into f of a divided by f of b minus f of a. After that, we will check for convergence based on tolerance, and we are going to set the tolerance to 10 raised to the power minus 5 and the maximum iteration to 100. After that, we will plot the function and its root, and finally, we will display the final root and results. So let's move to the MATLAB. This is the interface of the MATLAB, and we are going to create our new script by clicking on new script, and an editor window pop up in front of us. Okay, so we are going to develop the code of Regula Falsi Method, or the other name is false position method. So initially we are going to start our code with CLC that will clear the command window. Then we use clear that will clear all variables from workspace. Then we have close all, so that will close all the open figure windows. So clearing everything just to avoid the confusion. After that, we need to define our function. So f is equals to at the rate x, and we have x dot head 3 minus x minus 2. So we are working with a cubic equation. After that, we need to set our initial condition. So a is equals to 1. That is our lower guess. B is equals to 2. That is our upper guess. So we choose two starting points where the function changes sign, which is very essential for the false position method. After that, we need to check that if the initial guess brackets the root or not. So check if the initial guesses bracket the root. For that, we are going to use if statement. So f of a steric f of b is greater than 0. It will display the error that function has the same sign at the points A and B and choose different points. If f of A and f of B have the same signs, so this code throw an error because we need a bracketed root. After that, we need to set the tolerance for the stopping criteria at the maximum iterations. So basically, we need to set the parameters. So in parameters, we have a tolerance that we are going to set to e raised to the power minus 5. That is basically our acceptable error. And we are going to choose maximum iter to 100. Maximum number of iteration allowed. So we need to use a percentage sign here just to shift in commented statement. With the help of tolerance and the maximum iteration, we define that how close we want the answer to be and how long we are willing to wait. After that, we are going to plot the function for visualization. So for that, initially we are going to define x is equals to linspace, and in linspace we are defining a minus 1 to b plus 1, and then we have a 400 points. So that will generate 400 points between 0 to 3. Initially, at this point, they will replace a with 1. So 1 minus 1, it will give 0. And in the second, we have b is equals to 2. So b 2 plus 1, that is equals to 3. So basically, the starting point is 0 and the ending point is 3. And the range 0 to 3 will be distributed into 400 points. After that, we are going to plot x versus f of x, and we are going to set our color to red and style to solid line, and we are just setting a line width to 3. So that will plot f of x versus x with a red thick line. After that, we are going to use hold on command just to keep the plot active for adding more points. After that, we need to on the grids. This is totally optional. Turn on the grids. And after that, we are going to customize our plot by using X label. So in X label, we have X, Y label. So Y label, we have f of x. We need to set the title, that is Regula Falsi Method. That's it. Okay, so after that, we need to start our regular falsy iteration. So we are going to use a for loop, and I is equals to 1 to max iter. So initially, I am going to calculate the point C using regular falsy formula, or we simply say that a false position formula. So that is C is equals to A steric f of B minus B steric f of A divided by f of B minus f of A. After that, we need to check if the values of f of C is close enough to the 0, means the root found or not. So check if the value of f of C is close enough to 0. So for that, I am again using my if statement. So if ABS f of C is less than tolerance, then it will break the code, and after breaking, our if statement ends. So this will exit the loop if the solution is within the tolerance. Okay, after that we need to update either A or B based on the sign of f of C. So update either A or B based on the sign of f of C. So for that, I'm going to use my if statement. So if f of A static f of C is less than 0, end it, and B is equals to C, root lies between A and C, else A is equals to C, so root lies between C and B. So if f of A into f of C is less than 0, root is between A and C, else root is between C and B. After that, we want to display the approximate root in the command window. So for that, okay, so we are going to end our loop here. After that, we need to just display our results. So initially, I am going to display the approximate root in the command window. So fprintf, the approximate root is percentage dot 6 f backslash n. This should be backslash, and display the C, that is the result. After that, we are going to mark the found root on the plot with the black filled pentagon. So for that, I'm going to use plot C 0, and K stands for black color and P stands for pentagon style. Then we have to adjust our marker size. to 12 and marker face color to black. After that, I'm going to just add my legends. So legend, and for initially we have f of x, our main function, and finally the root. Okay, let's run it. So we just name it false position method. The approximate root is 1.521379, and in the graph we have a red line that is our main function line, and this star or black star, or simply we say that a stylish black pentagon, that represents the root of the equation. And that's how the false position method gets us to the root. I hope you enjoyed seeing both the code and the concept come together in MATLAB. So if you found this video helpful, don't forget to like, subscribe, and hit the bell for more visual coding tutorials. Let me know in the comment if you have any questions or suggestions. So thank you so much for tuning in. I'll see you soon in the next video. Take care.